Hello and welcome to Beginner's Physics in Craft Studio. We're going to be using visual scripting in this tutorial, and I'm going to show you basically how to get some of the physics components working and how we can apply visual scripts to them to get them to move around a scene. First things first, here's our scene, and it's got several different objects in it already. I've got a camera, which you can see there. It's just a normal camera with a perspective view, and I'm just basically fixed camera looking down upon the scene. I've got a ball, and I've made this ball. This is a model that I've made. It's a kind of sort of cuboid in shape with little spikes coming out of it, and that's being rendered by the model renderer over here. And also I've attached the physics component, and I'll talk a little bit more about that. And also you can see there's a script behavior attached to it too. Also in the scene we've got a map, and the map has got a map renderer on, making the map visible, and also we've attached another physics component to it as well. And this makes the map collidable with the ball. After that we've got a chest, and I've put a chest in here to basically show that you can create other things within the map if you want to add scenery or other effects, and you can make those collidable too. And I've left that out at the moment. I'm going to show you in the tutorial how to add a physics component to an object to make it collidable. So let's have a little look at the example project and see how it runs. So I'm just going to press F5 to quickly run the project. So here's our physics object, and it's a sphere, and within that sphere is our object that we've created, our model, and I'm using the keyboard W, S, A and D to move that object, kind of roll it around the scene. So this kind of thing is great for making marble games or kind of marble rolling games. And we can also just, you can see that I'm colliding with the map, and I'm also, but I'm not colliding with the chest, and we'll add a collision to the chest in just a moment. So I've selected my ball game object over here, and remember a game object is an empty just game object, and we start to add on all these different components. So transform is always added onto a game component because the transform component really locates that object, that game object, in that three-dimensional space. The next one is the model renderer, the actual kind of the visual, the ball that I've created. Okay, but remember that is just a visual. Okay, the actual object that's being moved around is within that sort of transform area. And then there's this new thing, the physics. And we've got three different tabs up here. We've got dynamic, we've got static, and we've got kinematic. Okay. Now we're going to just kind of look at dynamic for today and stick with that. You can change its mass, and obviously what mass means is its kind of weight. You can also freeze positions, and we'll get to that at some point. But right now you can leave all that blank. And obviously we want a sphere. We've also got other things it could be. It could be a box, and you can kind of see it there, what that looks like. And the box just about touches all the way around my object. You can change the shape of that physics area by changing its size. So I could say 2 here, and you can see that it changes shape there. So I'm just going to take it back to 1. Another thing is we obviously can have a capsule. Capsules are good for characters. And often when you play kind of first-person games, what you're actually playing within your hitbox, if you like, is often a capsule. And that's got a radius and it's got a height that you can change in there. And obviously the last thing is a map, and I'll show you what the map looks like later on. So let's go back to sphere. I'll put the radius so it just touches the outside of my kind of cuboid sphere that we made, the model. But the things to remember is that the model there and this physics component are kind of two different things. So for example, I could make the physics object a little bit smaller, 0.1, and it kind of disappears within that. Now let's just play my project, and you can see that what is actually happening is the model renderer is now cutting through the floor of the map, and it's because basically what's happening is the physics component is the thing that is colliding with the map, because the map has got a physics component added onto it as well, and so those things are touching, whereas the model renderer is just rendering wherever it likes, wherever the transform position is. So that kind of just proves that these two things are separate. So let's put that back to 1.5. So I suppose what I'm trying to say is whenever you create a model and then you kind of create a physics component around it, make sure that your physics component is as close to the edge of the model as possible. So how do we make this thing move? Well, let's close this and open the script and show you how that works. So here's the script that we're using to move our sphere around the map. The first thing we have to do is to create a local variable. So we're just using the update instance. So this update thing repeats itself 60 times a second. So it's being called 60 times a second. So here it says create local variable, and I'm creating a variable called pos, short for position, with the initial value of the global position of the self game object. So I'm attaching this script to the ball. Okay, so wherever the ball is, we will get back these positions, the X, the Y, and the Z position of wherever that ball is, and we'll get that at 60 times a second. The next thing we're going to do is create a local variable called target velocity with the initial value of a vector. And we're going to use this vector to actually push the ball in a direction that we want it to go. The direction we want it to go is going to be horizontal, left and right, horizontal if you like, and forwards and backwards. And we're going to call this, that's going to be part of the vertical plane if you like. And we're going to use these axis values of horizontal and axis value of vertical. And the axis value is really the input, that comes from the input thing, and we can find those inputs over here. So it comes over here and it's got a name, and we can actually write the name of the input here. Now you're thinking, well, where do I get the name of the input here? Well, if we go back to our home and we open up our cog and we go to game controls, it is just really these things here. It's horizontal and vertical. Often they are there as a default. So what we're going to need to do is make sure that in our cog, in our game controls, we've got horizontal, and we're going to make sure that we've got it set as a keyboard, and our key for positive axis value is D, and our key for negative axis value is A. So when none of these are being pressed, the value for the horizontal axis is 0. But if I press D, I get a kind of +1. It becomes 1. But if I get a key for negative axis, I get -1. And the same goes for the vertical. We've got a key for positive axis value, which is W, which is like forward. And we've got a key for negative axis value, which is S. So let's put those in and see what happens. So the axis for horizontal goes in the X, and the value for the vertical goes in the Z. And let's press F5 and see what happens. So what I'm doing here is I'm going to press A, and we're going left, which is great, and D, and we're going right, and now I'm going to press W, nothing seems to be happening, press S, right, and press W. So what's happening here is W is supposed to be taking us forward through this plane, and S is supposed to be taking us backwards. Now the easy solution for this is we can just go into administration, we could swap these around. Another way of doing that would be we could reverse the axis value by putting this in. So we could say axis value, we could be 0 minus the value of the axis. So let's just put that in. and press F5 again. And now I'm pressing W and it's going forward, and I'm pressing S and it's going backwards. And that's a little bit of maths to help us reverse that. So we can now roll backwards and forwards. So let's continue with our explanation of what's going on. Down here I've got a print value of horizontal, and that's just to check that these are actually outputting numbers. The next thing I've done is I've actually added a little comments here, which is speed. So we're going to set the value of the target velocity, which is this vector up here, to the target of the velocity, and I'm going to times it by number. So I can increase the speed by timesing this by a high number, or I could decrease the speed that I'm moving at by lowering that number. Finally, we actually apply the force of whatever these axes are. Now, most of the time when we use input, we're using an if command, like is this button down or was this button pressed. But with the axes, what's actually happening, whenever I press the buttons, the axes change their value. So I don't even have to put an if condition down here. Whenever I'm pressing W, these values change automatically within the update. So as the update's spinning around and round and round and round, it may get a new numbers inputted in here. And as those new numbers are inputting here, finally we get to the last thing, which is apply force of the value of the target velocity, which is a vector. So it's going to have different vectors pointing in a particular direction, and it's going to apply that force on the value of the self game object. Now it says here dynamic body, and we can find this apply force in physics. So in components, we can see we've got three new pieces in here. We've got apply force, we've got teleport, and we've got linear, get the linear velocity of whatever the dynamic body is. So we can apply the force of the value of the target velocity on the self game object, and here's another important thing, dot physics afterwards. If we don't put that in, you will get an error because it's trying to actually move the kind of model renderer and not the physics component of the game object. And it's the physics component thing that's actually going to be moving us around the map. So just to sort of go over this apply force again, we've got a drop down menu here which says force and impulse. Now force, when we are applying force, we're actually almost like, if you can imagine, pushing it forwards. So the game object, the physics part of the game object, will slowly accelerate. So it will accumulate energy. Okay. If we were to apply impulse, impulse is like it's done immediately. So it's like it's already got that energy and it's moving at a particular speed instantly. So impulse is more instantaneous, whereas force is more likely to start off at a 0 and then accelerate up, depending on how long how long we keep these values being inputted. But for now, what I'm going to do is I'm going to leave it a force for the time being, and we'll see how that works. So I'm going to get rid of this as well because we don't need print anymore. So to delete blocks, if you're on a Mac, you can press the function and delete key. And I think if you're on a PC, I think you just press the delete key and it works. So anyway, if we press F5, we can run the project. And we can see that we now are colliding with the map very effectively. We might even be able to jump over the top. Not quite. And we can go into this room over here. And you can see clearly as well, we're not colliding with that chest in the corner. So what I want to do is I want to show you how to make the chest collidable. So here's the chest in our scene, and we're going to just make sure it's selected. I'm going to just pull it off the floor for a bit and lift it up so we can kind of see all the way around it. The reason I'm going to do this is because I'm going to be adding a physics component to it, and I need to make sure that physics component fits it quite snugly. At the moment, what we're actually seeing is just the model, okay. And as you see, when our other physics component, our ball, rolls into it, it rolls straight through it. Okay, hasn't got any physical properties. So with the physics component, we are going to add some physical properties to it. So as soon as I click this button over here, add physics, it defaults to dynamic and it defaults to box. And we can start to see a kind of a white wireframe box that is sort of surrounding, slightly intersecting our chest. It's a little bit wide at the bottom. So what we need to do is we need to make sure that this wireframe body actually just snugly fits it on the edges, so we need to make it a little bit wider. And we can see that the physics has got it's got its X, it's got its Y, and it's got its Z arrows over here. So we need to extend the red, which is the X. So let's put it onto 2. And as we see, that kind of fits it quite nicely. There's a little bit of room both sides. Now you can change this, so we could say let's give it like 1.8 and see what that does. Right, okay, well that cuts in a little bit, so maybe 1.9 would be the number we need. So 1.9, yeah, that seems to do that kind of well, and it's a little bit it's too deep at the moment, so we'll just reduce its depth, which is the blue, and we'll put that about 9 too. Oops, that's what have I done? 0.9, I meant 0.9. There we go. Okay, how's that look? So that looks pretty snug all the way around. There's a bit of a gap at the bottom, but I don't think I need to worry too much about that. Now at the moment it's dynamic. Okay, so if I were to run it by pressing F5, we would see the box would let's just actually move our ball in. Maybe our ball can move it around. Yeah, you see our box can, everything's movable. It's jiggling about a bit. Not what I want. Okay, well, it may be what you want, but it's not what I want for this project. So the reason it's doing that is because it's set on the dynamic. We can set it on static, and it says here, static bodies can't be moved and aren't affected by gravity, useful for scenery. And I suppose this chest in the corner is a part of the scenery. So let's put it onto static. It remains as a box, but we've got other options here as well. We can have sphere or capsule or map. Box is what we want. We can even have it as kinematic. Kinematic bodies can be moved programmatically but aren't affected by forces, useful for moving obstacles. I'll talk a little bit more about that, and we'll talk about how to move things. In our next tutorial, we'll probably be having something like moving platforms, and we'll probably turn this into a marble rolling game with moving platforms. Maybe even keys. I think what I'll do is I'll put a key in this chest, and you're going to have to go and collect the keys to open doors and to carry on our rolling adventure, if you like. Okay. So kind of Dungeons and Dragons marble rolling adventure. So what we're going to do, we're going to make sure it's on static, and we're going to pull this object down to the floor. Make sure it's neatly snugged in there, not clipping anything. That looks pretty good. And press F5, and we can just test that scene to make sure that our marble doesn't roll into it or through it or anything like that. Let's go through into this door. Yep, so there you go. We've added a bit of scenery to our map that isn't the map. Okay. So just to go over things again, you're going to always need a camera, obviously, in your scene. You're going to need an object that's going to be moving around. We're using a sphere, but there are other options in here. You're going to have some scripted behavior, and we've looked at how we can write that script. And in the next tutorial, I'll be extending that script a little bit and adding a jump too. we need a map, and our map needs to have a physics component attached to it as well, and that needs to be static, and you need to actually make sure you goes down to the drop down map section. Once you go down to the drop down map section, you can actually add the map to it, and we can click that box over there, and that means the map shape becomes like a solid object, okay, that can collide with our dynamic bodies. And I've added a little bit of scenery in here in the form of a chest, and we've covered that with a static box as well. And we can change the size of the box and make sure that it fits our model very snugly, so there's no so things don't intersect or collide or kind of slip through each other, which would ruin the illusion that that these things are solid and not just made out of numbers. Okay, so I hope that's helped. Stay tuned for some more physics tutorials. They'll be coming in fast and furiously, I should imagine. I know there's been a long wait, but do stay tuned, and I'll get them out to you as soon as possible. Any questions about this tutorial or any of my tutorials, leave them in the comments below, and I'll try and get back to you as soon as I can. Until then, thanks for listening, and goodbye.